Welcome to another edition of Espresso the Evangelist. I'm Dave Caro. With me today is Dave Murphy.
Hello, Dave.
And Lizzie Erdley. Hi, Lizzie.
Hi, Dave.
Thanks for joining. Today we're doing the third part in our series on foundations for effective experiments. We've talked about forming our hypothesis, then we talked about metrics, and today we're going to talk about power, right? So I'll start by just kind of giving a really simple kind of intuitive, like what do we mean by power? So at its simplest sense, power means the more users you send through an experiment, the smaller a detectable effect you can reliably observe, right? Right. So hopefully that's just a more people going through, smaller thing you can notice. You send through 1,000 people, something would have to be a really big shift for you to reliably observe it and think it's not just random chance. And if you have a giant population, bigger, let's say 100,000, then you can detect a much smaller change in something.
And I think this relates back to two of the things that we brought up in our previous sessions, which one is the sensitivity of a metric. When we were talking about metrics, we talked about the need for a metric to be sensitive enough for us to notice a difference.
It needs to move, right?
It needs to move. And then back when we talked about a hypothesis, one of the things we said is that we wanted our bookings, based on the experiment we were running, to increase by 5%. So that's the effect that we want to achieve.
Right.
Now, it may not be the effect we want to notice. Lizzie, how would you describe how we would then relate that hypothesis to the minimum detectable effect that we're trying to achieve?
Yeah, so when you're designing an experiment and deciding how long to run it, the minimum detectable effect is a really important component of that. And I think I would say that is the smallest effect that you care about. So maybe you're aiming for a 5% change in bookings, but maybe if you see a 4% change in bookings, that's still a really big win and you still really want to know about that. And you want to make sure that your minimum detectable effect covers all those impacts that you care about.
Got it. So don't set it right at the best case goal. Set it you want to have a little bit of range so the meter means something.
So then how do we calculate power? What's the process that we go through? What are the variables that go into that calculation?
Yeah, I think Lizzie can help us here with sort of the basic inputs to a power calculation or what.
Sure. So the basic inputs would be, the value of the metric, the baseline value. Then if you want to work out the smallest effect that you can detect, you'll need to input the sample size. Or if you want to work out what sample size you need to detect a given effect, then you need to put in that effect that you're aiming for. You'll need to know the rollout percentage. So if you're going to do 50-50, or if you're going to do, say, 10-90. And if you're measuring, say, a means metric, you'll also need to know the variance in that metric.
Got it. So there's a fair amount there to unpack. I think let's layer up from the sort of basic case, right? Which is that effectively you're going to either start with knowing you want to achieve a certain amount of detectable difference, and you're going to ask, so how many users is that going to take? Or you might say, well, I think that I want to run this experiment for about 2 weeks, and I know that I get this many users. What's the minimum detectable effect I can pick up in 2 weeks? Right. So you could kind of work from either direction, right? And I think in our Help Center calculator for this, a little more detail on what you would put in, right? So basically, the big moving parts are, more users makes it easier to detect more subtle differences. If I think there's going to be a massive change, maybe I don't need a whole lot of users. But if I'm optimizing something that's been around for a while, I might need a lot of users. Right.
And I think one thing you need to consider when you're talking about the duration of an experiment is not only when am I going to achieve power, but when am I going to also get a representative set of users. So if, for example, you want to go typically a week, because then you get weekends and weekdays depending on the type of traffic that you're going to get. So it's a combination of both of those that you need to consider.
So even though while technically if a big rush of users come through, I might reach my goal of how many users I needed to achieve power. But if I'm doing that because there was a flash sale on a Tuesday, and I've only been running for 2 days, I probably should chill and let it run for at least 1 or 2. I think a lot of times people use 2 weeks because it gets you through 2 sets of weekdays and weekends.
Yeah.
Right. Cool. Awesome.
So I guess the next question I would have is, Split has a platform for doing this. We've got statistical settings all set up in place. It can be modified. What did we choose as the statistical settings?
Why don't you catch us up on
how and why would you modify them?
Sure. So we have two statistical settings. The first one is the confidence level, alpha. So this essentially sets how sure you need to be before we say something is statistically significant. So the default in split is to use a 95% confidence, and that's because it's the industry standard. But if you wanted, you could either increase that to say have a 99% confidence, or even decrease it to just 90% confidence. And so it just means that you need to see a bigger difference for a result to be significant if you increase that, say from 95 to 99, or if you were to go from 95 to 90, then it's easier to reach significance. So the reasons why you might want to change that is usually dependent on the cost of a false positive. So if you're about to invest loads of time and resources and money into iterating on something or rolling something out, then you want to be really sure that when you see an impact, it's not just noise. So then you might want to increase that up to say 99% confidence. Right. But if on the other hand, you're just making a quick change and you just want kind of a best guess scenario, and it's not going to be too costly if you get this wrong, then you might want to move that down to say 90% or even 80%, so that you have more power to detect a difference for the rest, everything else fixed. And then the other statistical setting we have is something that we call the power threshold, is also often called beta. And it tells us essentially for the minimum detectable effect, when we're working out the sample size, how likely does it need to be that we would be able to detect that minimum detectable effect? So essentially, if you are aiming to detect the 5% change in bookings, if you have a power threshold of 80%, then that means your power calculation will make sure that if you use the sample size the power calculation recommends, then if the true impact is 5% change in bookings, then you will have 80% chance of getting a significant result. So maybe you want to be sure that if you do have that 5%, then you are definitely going to see a significant result. Then you might want to increase that power. But on the other hand, if you reduce the power, then you won't need as much of a sample size to run this experiment.
And I also want to kind of go back to one of the things that you said, Lizzie, about the rollout plan. So if the rollout plan is 50-50, we typically call that maximum power ramp because you're getting even population on both sides. But you can, and there are reasons to run an experiment that might be 90-10. For example, you might want to roll out this new feature to only a very small subset of the population because there's some risk associated with it, but you want to see how that plays. Can you still run an experiment at 90-10, and what implication does that have on power?
Yeah, absolutely. You can definitely run an experiment at 90-10. The implication to power is that you will need slightly more users to reach a given minimum detectable effect than you would if you were doing a 50-50. So the kind of most efficient setup is to do a 50-50, so 50 in on, 50% in off. But doing 10% in on, 90% in off is perfectly valid. It just means that you'll need more users to reach the same sensitivity of the test.
I think what's interesting, we were talking about 50-50. It's important to remember the 50-50 isn't about needing an equal sample size. It's about if you've got the whole population to work with, you're going to get more users passing through. Related is, if you have a choice between, say, 90% on and 10% off, because you're thinking, well, I only want, I don't want to expose this to a whole lot of users. That's a much better thing to do than to say, well, I'm first going to filter my user population down to a small number and do a 50-50 within them, right? If I say I've got 100,000 users and I only want 10,000 to see the on experience, for goodness sakes, don't run an experiment with 20,000 users where half of them get it and half of them don't. You're so much better off having 90% of those, 90,000 of them getting the off and 10% getting the on. Right, Lizzie?
Yes, that's right.
One other thing that we talked about earlier, Dave, was that metrics can be different, right?
Right.
So when we look at the metrics in split, we might see some that show statistical significance and others that are inconclusive. And I think the reason for that is because we're measuring different things. So as an example, if you take a look at checkout as being a metric,
false, yeah.
It might be, did they check out? Yes or no.
Right.
If you're asking how many items were in the cart when they checked out, it could be 1, 10, 20, however many items are in the cart.
Right.
So there's a balance between the variance in the data and then the difference between the means. So if you've got the combination of those two things will impact the amount of power you need.
Right, so it kind of gets back to, remember, one of the fundamental things we're trying to do is avoid the chance that noise or random stuff is tripping us off, right? Like and for something that it can only have two states, on and off, there's not a lot of noise there, right? If people can put any number of items in the cart, there's a lot more variability, and that will affect kind of how sensitive the experiment is, right? So that's why each of the separate metrics is being calculated, like you say, could, even if they're all kind of going in the same direction, one of them could turn green before the others because the one that didn't turn green may just have more kind of variation and noise in it, right?
Yeah, and you may care a heck of a lot more about whether or not they checked out and maybe the size of the car than the number of items. Yet it still might be an interesting metric to check.
I think related to power, it's also important to point out that if you see something as not significant or inconclusive, that's not the same as saying that there was no impact there. It depends on the power. So this is why it's super important to understand your minimum detectable effect, because there could be an impact, you just didn't have the power to detect it.
Yeah, so that's a great point to add, Lizzie. And I think, I'm not sure we mentioned earlier, but in the Help Center, we've got topics on this, and we've also got a calculator there. So if you want to do some what-ifing, just a few inputs and you get your numbers. Yeah. Awesome. Thanks, Lizzie, so much for your time.
Thanks.
Have a great day, everybody.
Thank you, Dave.
Let's close out another Espresso with Evangelist. Good times. Take care.